Welcome to Cloud Native Apache Pulsar Development 101 with Python. So this is Pulsar for Python people. But what is Apache Pulsar? You know, how do I code against it in Python 3? How do I consume messages? How do I produce them? How do I interact via other protocols like MQTT, WebSockets, and Kafka? How do I use Python for making functions? And what are schemas? How do I use them? And why do I care? I'm Tim Spann. I'm a developer advocate at Stream Native, like I mentioned before. I'm interested in the flippin' stack, Flink, Pulsar, NiFi, working together in an ecosystem of lots of cool open source projects. I've been doing this for a number of years in the big data and cloud space. I work at Stream Native, founded by the original developers of Pulsar, and we're out there to help people with Pulsar, get you into a cloud environment that scales and is managed for you. I run the FlipStack weekly newsletter, has a lot of cool content, videos, articles, code. Sign up and get it once a week. Free training is available if you're really interested in Pulsar. We give you an environment you can code with, and you get some really good training materials. Walks you through with some quizzes along the way. Pretty cool way to learn how to do Pulsar. But what is Pulsar? It is a unified messaging platform. Why? Well, there's a lot of different messaging systems out there, different types, they do different things. Yahoo saw that and they couldn't find one that met all their needs. They did not want to run multiple messaging systems because they wanted to interop. They wanted just one scalable architecture to do that. Pulsar unifies multiple messaging protocols, messaging styles, and does this in a pretty unique way. As expected with messaging, all your messages are guaranteed. Very resilient system, and you'll see why with the underlying architecture. And you can scale out as big as you need to. There are a lot of large companies scaling out to petabytes, thousands of machines, as big as you need to go, or if you're just starting out with, one Docker container. Cluster's pretty straightforward. What's nice is because of this separation of components, these are a separation of compute and storage, makes that very easy to get up on Kubernetes. We've got a Helm chart and operators for you, all in the open source. Don't need to use any commercial product there. What's nice is the different layers are isolated, and with such, we've isolated the metastore out. The metadata store is used for metadata that both layers need and for discovery of services. This is now independent of a particular implementation. As of right now, we have Zookeeper, RocksDB, and etcd coded. And because it's open source, I'm sure people will be adding more. Got a lot of developers out there. The Pulsar brokers handle all the messages, make sure things are routed, connected, with some caching in there, automatically load balance, handles segmenting the topics. These are very easy to scale out. They don't need much disk. These are very inexpensive, smaller brokers. They can scale them up and down very easily. Not have to worry about the storage. Storage is in Apache Bookkeeper. These bookies have the messages and cursors pointing to everything, and they segment them up to optimize storage. Makes it very easy. You don't have to have thousands of these giant SSD nodes. And what's cool as well is you could design your topics to automatically tier out to storage such as S3 or different object stores or HDFS. Makes it easy for you to store as much data as you want and not have to worry about that when you need to consume messages, even if you're going back, through years of data, petabytes, doesn't matter. Pretty standard in messaging. Publish and subscribe. Producers send messages. Ordered named channels called the topic. Messages have a payload, whatever that may be, along with some additional metadata and properties you put on there. Brokers make sure things are routed properly and everything's connected. You create a subscription to topics to get what kind of data you want. These are the magic way you decide how I want this system to run. You know, do I want it Kafka style streaming? Do I want a fan out? Lots of options there. Your consumers get these great messages. These subscription modes are important because this gives you some cool different styles of messaging. With exclusive and failover, you get a guaranteed order. You get a single consumer. With failover, if that consumer can't function, the backup takes over. This is how you do Kafka style streaming. This is if you need things exactly once in an order. You know, your traditional Flink, things like that, work with that type of streaming. That's a great way to do things. But remember, it's the consumer that decides that. So it doesn't matter how you got those messages in there. Consumer decides, I want this streaming style, you get it. If you decide I want a work queue, give me, you know, I'm going to have 1,000 little apps running there. And as soon as they can get something to run, they're going to run it. You know, all of them active. Don't care about order. Just process this stuff as fast as possible. Shared is great for that. Key shared. Let me split the difference. Can have multiple active consumers in order, but it's order for a key. So this is good if maybe you're doing CDC. Each one has a table. Make that the key. Have each table consumer get their own table. All those rows in that table be in order. Lots of other examples for that. What's a message? A message, data obviously. This could be raw bytes, but you can make sure that it conforms to different types of schemas. Key, highly recommend it. It's helpful for reducing storage. If you need to partition, if you need to find data randomly later, having a key is important. If you can't think of a key, I like to just auto-generate one just to have one. Could add any kind of key value map properties. These could be metadata that you need along with the message without messing with that payload. We like to name things when it gets produced so you know who sent it. Good for debugging and other purposes, auditing. Sequence ID so you know how it's ordered. Obviously something you need if you're going to do streaming. Lots of things you could do. Those are really great basic things, but I want to get data in and out, especially with Python. So we support functions. These let me run basically like, you know, in Amazon you have Lambda, or you could think of database triggers. They get triggered by events that occur in a topic or multiple topics. Pretty straightforward there. A similar concept are connectors. These are sources and sinks. These you set some configuration, data automatically goes there. That's a great feature. The protocol handler support is important because this lets us not just do the Pulsar libraries. I could use existing libraries for ActiveMQ, for RabbitMQ, for Kafka, for MQTT. This makes it very easy to not have to change code. Lets you support unified messaging. You want to process data. I'll show you some examples today. Flink, Spark, Presto. Makes it easy for you to do that. We mentioned that tiered storage. Important once you get a lot of data and you don't want to store it all in these expensive, you know, SSD drives. Put it on that cheap S3 storage. So a function takes the messages in, can log things to a special log topic, send it to one or more outputs, or not have an output to a topic. You could, you know, update a database or do something special in there. Got support for Java, Python, and Go. Use any kind of libraries in there, including machine learning. Pretty straightforward. I have a function that takes in a chat message, which is just, you know, JSON, but I take it as a big text file. If I do the use our special library to build my function, I can get access to a context. It gives me logging, gives me the message ID. It's a nice feature. And then when I do a return from that, it goes to that output topic that I specified in my DevOps setup. If I want an advanced way to run these functions, by default, we just run them as a process or thread within the broker. You want to do that in a more powerful mechanism. We can run it in Kubernetes with function mesh. This makes it very easy to have a scalable architecture for however you're going to run all these different functions. And there you're setting a couple of Kubernetes files up. kube control deploys them, uses all the standard APIs, and it, sets up a namespace to easily connect with that Pulsar cluster it's associated with. For those different protocols, MQTT is an example. If you see here, it's not a simple little tiny layer there or some kind of interpreter or something that just converts A to B. We have a full implementation of the MQTT libraries. So these protocol handlers work as if you now have a MQTT broker. And what's cool is it doesn't matter how your data gets into or out of Pulsar. You pick the library you're comfortable with. I send Kafka in. I want to get it out as Pulsar, or I want to get it as MQTT. Doesn't matter. It's that same data. An easy way to access your data is through Pulsar SQL, which under the covers is Presto Trino. And it lets you access the data even if it's already in that tiered storage. So it lets you do a quick SQL and see what's in your topics. If you want to do micro batch coding or maybe some ETL, Spark is great for that. We got a great Spark connector. Connect right to your topic, do a SQL on it, and then you can figure out where you want to write the stream. It could just be the console if you're monitoring something, or you could dump it to a CSV, JSON, Avro, Parquet, some other file, maybe combine it with other things, maybe do some machine learning. Pretty easy to do. You could do some real-time ETL and continuous SQL with Flink. This is a nice way to process your data at scale, event at a time. What's nice here is this can be done with either just a SQL interface, or you could use one of Flink's languages like Java, Scala, or Python. The queries are pretty straightforward. Select, columns from a table, that table being a topic. You could do order by and group bys, max, all those kind of fun things you expect in SQL. In the overview of this, kind of think this is a universal gateway. Can be used as a buffer while you're doing processing in different places. Very easy to get in and out of a lot of different sources. And you can do a lot of processing in here, whether it's filtering, aggregating, enriching, deduping data. And it's nice now all these systems are decoupled. You don't have to know if someone wrote something in Java or they wrote in Scala or it's coming from this database or that database. All I got to know is one of these protocols to get in and out of Pulsar. Pretty straightforward. To make things have a contract, it's great to put a schema in there. It's really easy to do that in Python. If I have a schema, whether it's Avro, protobuf, or JSON, makes it very easy for me to know what those fields are, what it should look like. Makes it easy to format these tables we might want in Spark, Flink, or Presto. Example of an architecture here. We touched on those topics already. I want to show you some code. If you want to do this at home, I've put all the directions in the slides. So you don't have to, I'm not going to walk through them all because we're not have a super long session. I'll come back to a couple that are maybe really critical to highlight some things. But here you could download it if you want to try it as like a standalone in just like on a small node, like maybe EC2. There's instructions for doing it with Stream Native Cloud, which we have a free tier, or some other options there. You could also do it in Docker. You could use the Kubernetes Helm chart, or go to our academy and you get to a cluster for a couple of days connected to a Visual Code instance to do some development. But let's look at some real code. Let's look at some demos. I have a bunch of open source examples here, fully documented. This one is for weather, and this gives you a little idea of what's going on here. I show you different runs, how we interact with things, just to make it easy. All the source code is here, makes it very easy for you to run these things. Let's take a look at some of the source here. This is simple Python. The things that you need here, you need the Pulsar library. You just install that with pip, and the one for schema. Now it depends on your infrastructure. lots of different infrastructure supported. If it's not, you have to compile it from C++, but we've got the full build for that if you need to do that. And it'll even run on Raspberry Pi. If I want a schema, which if your data is consistent, has fields, let's do that. Let's create a schema. This is an example. I want one for my weather fields. So this is as simple as it is. That's all I have to do. I don't have to know some kind of special schema language. Create a class, put the fields in it. We're ready to go. So here I'm connecting, grabbing some stuff from a sensor. The part that's important here is connect to my Pulsar cluster. If I have authentication, I've got that examples in there. We support OAuth and tokens and a bunch of other ways. But just to keep it simple, I've just got my local hosted environment here. I've got my topic. If you look at the topic, it's a little unique. I didn't go into this as we're trying to go through pretty quickly. But Pulsar is multi-tenant. So I could have a lot of different people using this. So I can have hundreds of thousands of topics. And the way to keep that clean and secure is I have a tenant. Say that this one's for everybody, but I could have one specific to your group, your company. Then underneath that, I make any of the namespaces I want, maybe per app, per line of business. And under there are my topic names. So it keeps it nice and isolated, easy to work through. Here is where I define the schema. I just say JSON schema with this class I set up here for weather. And if I wanted Avro, I would just say Avro schema. And I've got an example of that documented there as well. I set a couple of properties. And that's really all you have to do to be able to set that up. And then I have a loop that's just going through the sensor. When it ever gets new data, I just set up a new weather record. Set all the fields, and then just send them along with that key that we mentioned before. And I'm just creating one from a UUID, and then boom, it's sent. Let's actually go to that device, and I'm going to run that code here. First thing it does is connect to the cluster, build that producer, and now we're sending data. I'm printing it out just so I can see that it's working, and it's for debug. Obviously, in your code, you're probably not going to want that way. You have lots of different ways you might want to run your Python. Could be in a notebook, could be somewhere else. This is good to see that the data is coming in. I know it's happening. That's great. Now, if we were going to do the Avro version, if we could take a look, the only difference in this whole thing is here I say schema is Avro. That's it to make that different. Pretty straightforward. Now, I can connect to Presto from the command line, or I could use, there's some graphical tools. I don't know how well you could see this, it's pretty dark, but I just have a select star here with just a couple fields I want. I could just browse all the topics from my tenant and namespace. Presto sets that up for me, and I get access to even all those metadata fields, like the event time, the message ID, the key. And I could even put those in my queries, like this message ID if I want. Pretty straightforward. Presto is pretty quick. I could change this query and do something like a count. Let's see how many rows we have there. 81, 83. We're adding more as we're running this, which is the good thing to see. Nothing crashed. Here I'm doing Flink. And that is a similar way to do this, but this does this continuously. Now, the thing to show you in that is that there are a couple of different settings you need for that. If you're interested in other examples, I have a lot of different examples, especially for Python and Java, as those are pretty common and a nice way to be able to go through these things without too much work. So I've got some examples here, and I've got some functions. Maybe we should go into a function. I got one in Visual Code here. This one does sentiment analysis. It's pretty straightforward. I'm using the function here so I get that logger so I can log it. So it comes in. I just parse the JSON there, and I build, just return the sentiment. Pretty straightforward. And then how I'm running it, here is I have an example. Let me reload this. It's been sitting here too long. So hopefully I didn't crash my system here. Okay, so I'm just going to put a question in here. Is today the best day for demos ever? We'll see if everything's working, and it is. So that's cool. And we can look at the publish time for all the new messages coming through. That's great. Is Apache Pulsar cool? Great. How about great? And I'll change my name here. And it's giving me back a positive. So what you're seeing here is an HTML form that's just doing a WebSocket call to Pulsar, and that's going into a topic. Down here is a separate consumer that's getting the results of that function. I know it looks like it's instantly showing up here. It is making that WebSocket call to Pulsar. Pulsar's triggering that function that does sentiment analysis. It sends it to another topic, and that comes out here in my HTML page with live WebSockets. All the source code for that is out there. Pretty easy to do. We are running Presto. Presto is a nice interface to show you what's going on. You can see how long things took, how much data was accessed. Pretty cool way to do that. Same thing with Flink. As those jobs are running, we could see all of that happening. Just trying to get you a good example of Flink. Here we've got most of another example documented. It's pretty straightforward to do these things, but like say we wanted to do some Flink. If you don't know how to work with Flink and Pulsar, just take a look at my code. I've got a lot of examples out there. Like here shows you how to build a catalog. So if I'm logged into Flink, I create a catalog. If I pasted it correctly, it's good to copy and paste, properly here. So let's go to this one. This air quality is another example. Pretty straightforward, but I'll create a catalog for Flink. Flink can connect to lots of different data stores, which is nice. So if I wanted to join, say, Pulsar topics with a table from something else, I can do that. That's pretty cool. Let's see all the topics we have. Let's describe one. We're doing Pi weather is the one coming off that device there. So I could just pick a couple fields here. If they have a reserved name, you'll probably want to make sure that they're in quotes so that you don't get those lost. So this is Pi weather. When in doubt, use those quotes. So this is going to launch a Flink job that could be spread across a giant Flink cluster. And again, you could wrap this in some Python or Java or Scala code. The job has shown up. It is starting to process. You can see it's a table source scan because I don't have any joins with any other topics, but I could. So this is running. So as long as I'm still sending data here, it should start showing up in Flink. Again, lots of different systems can show you this, but as those records are coming in, they're showing up over here. And continuous. I'm not rerunning the query. As an event comes into my results. I could have wrote this as an insert into, put that into another topic, or insert this into another catalog. That could be a data store, and that is as easy as the code is. Makes it pretty straightforward to run these type of applications. And the code, even if you're doing security, nothing's too hard here. Do your processing. That's your hardest part. Connecting into and out of Pulsar is easy, whether you want to use MQTT, you want to use sockets from Python, you want to use the Kafka protocol, pretty straightforward. Data comes in, maybe it goes into a function or to a sink, comes out if you have an output there, and anybody can consume it. I could have thousands of consumers coming off the same thing, same data. Just decide on your own which kind of subscription you want. Pretty straightforward. I have a lot of examples here we showed you, so you can get started pretty easily. Please join the community if you're interested or have some more questions. I am available all the time, which means maybe I shouldn't tell you that. I'm too busy. Don't contact me. No, if you have a question, please reach out. I'm always looking to put out some cool new demos or help people with some problems or bring back suggestions to the community. Thank you for joining me. I'm going to have some meetups soon and some other talks. If you want to see some different queries, please feel free to let me know. I'm always looking to do some cool new stuff. So here, this is ANSI SQL. So if I want to do something like get a max, let's do a max on, say, temperature. Is that a float? Okay. I could cast it to a number if I defined it as a string. Sometimes you define things as a string just because you're not sure. So far 82 degrees. I may need to turn my air conditioner on. It's a little loud. I wish I had central air here. What are you going to do? So that's not getting any higher. Pretty consistent if we look here. Hasn't gone up. We could have done the minimum. Could have picked another field. Lots of options there depending on what you want to do. So thanks for attending my talk. I hope you learned a little bit about Pulsar and why you should start coding today with Pulsar and Python. Again, if you want to do it in Go or Java or Scala or Kotlin or C++ or C# or Node.js or any library, anybody who could speak WebSockets, or someone could speak MQTT or Kafka, please start coding. Put your messages in Pulsar. Makes everything easy, regardless of what type of streaming or messaging you intend to do.